Alright, hey Team Geometry, hope you're having a great spring break. Here is a video that will hopefully help you with inscribed and central angles. I know it's a tricky topic, so let's get into it. So let's get into some examples. You know the drill. At any point, feel free to pause. Why is this not working? There you go. Feel free to pause and do the video at your own speed, or do the problem at your own speed, and then you can unpause and see how I've done it. Let's get into number one. So they give me this arc CB as my target. They say the arc CB is unknown, 102 is an inscribed angle, CD is the arc right here. It's given, the measurement of arc CD is given as 140. Alright, so like I said, I know 102 is an inscribed angle, and if I look, the intercepted arc is the arc BCD. So B to C to D, that arc right there is my ice cream to my cone. Alright, so if the inscribed angle is 102, I know the intercepted arc should be 2 times that, which is, I believe, 204. And since they told me that CD, which is a piece of that, is 140, I think I'll be able to find BC with some subtraction. So, with some subtraction, I end up getting 64 degrees is my answer. That's the measure of the remaining arc. Alright, next up, let's go over here, example 2. Similarly, I see this inscribed angle right here, 40 degrees. Its intercepted arc should therefore be 80 degrees. And I notice I have a full circle here. I know this is 80, this is 144. My missing arc, I know if I added them all together I would get 360. So, in other words, if I want to get the measure of the arc Vx by itself, I need to subtract 144 and 80 from 360. And I believe 144 and 80 together makes 224. I think if I subtract, I will end up getting 136 degrees for the arc. And is that a choice? It is indeed. Alright, on to the next example 3. What I notice here is they have given me the diameter. I can tell that's the center because they put a point there and it looks like it. So this is the diameter, so I would probably use that knowledge to know that this is a semicircle, aka 180 degrees, and this is also a semicircle, aka an arc with a measure of 180 degrees. They want me to find an inscribed angle. Well, let's see what I know. If ED is 110, I think I can find, let's see, 180 minus 110 will give me 70. I believe that will be the measure of arc CD, because again, the measure of arc EDC is 180, subtract arc ED, that's 110. What I'm left with is, like I said, 70. So if this arc right here is 70 degrees, its inscribed angle should be half that, or 35. And let's jump to example 4. I have a quadrilateral inscribed in this circle. What do I know? I know this arc is 52. I don't have the center being used, so there's no semicircle or 180 degree arc here. And I'm looking for the arc KL. What else do I know? I know 123, okay. This inscribed angle has an intercepted arc that goes W to M to L, I believe. If you look at this, the intercepted arc goes W, M, L. Well, if this is 123, its intercepted arc should be twice that. I believe that is 246 degrees. Well, combined with the fact that they give me the arc KW right here as 52, I think the only piece that remains then, the only arc that remains is KL to give me my full circle. So if I took 360 and subtracted this 246 and this 52, I think I'd get my KL. So all 3 arcs must add to 360, which means if I take KL, what's 52 plus 246? I think that's 298. So then to find KL, I would simply need to subtract 360 minus 298, which I think is 62. And that would be D. Just a pointer. When doing 360 minus 298, I did 360 minus 300. But that was too many, so then I added 2 back. Alright, so there you go. Here are 2 more bonus examples. 11. We'll take a look at this one first. You know the drill. Pause it. See if you like the steps I end up taking. If you get the same answer as I do. First step, I use the inscribed angle, angle L. And if you notice angle L, the intercepted arc is TSR for that angle. So the arc TSR has to be double 95, aka 190. Well, let's see here. If this arc RST or TSR is 190 and TS is 100, SR, which is left over, should, I believe, just be 90. And now I can say the only thing I'm looking for is I don't know arc LR. Again, I'm looking for this inscribed angle, and that's why I want LR, you'll see. If this is 90, this is 100, this is 130, I can find this because I know a full circle should be 360. So let me take my 130, my 190, that gives me 320, and since a full circle should be 360, what's left over would be the 40-degree arc, LR. Again, make sure you remember, like, as you're doing all this math and subtraction and adding and all this and that, it needs to mean something. So like 130 plus 190 means take this arc and add to it this whole arc. That's 320. 360 means a full circle should be 360 degrees, but I'm taking away the 320 that I got that was going from L to T to S to R. So the remainder is 40. This 40 actually means something. It means this arc right here. Okay, so now I want this angle, which is inscribed in the arc LRS. LRS I can see is 130 degrees. 90 plus 40 is 130. Half of 130, I believe, is 65. And last but not least, alright, number 12, pause, take a moment, solve it yourself. So once again I notice they've given me the diameter, which means I will probably use the fact that this arc, LEN, len, is a semicircle, which means it's 180 degrees. So if this whole arc here is 180 degrees, the fact that L to E is 114 enables me to find arc EN. Looks like men. So the measure of arc EN is 66 degrees. Well, if this arc right there is 66 degrees, the inscribed angle should be half of its intercepted arc. I believe 33 is half of 66. So now it's time for us to say we've done this. Good job all around. And now I'm going to go watch some more SpongeBob.